Hello everyone, welcome to Dimma Tutorials Online School. My name is Victor Onimisi. Today we are going to be looking at JAMB 2018 past questions. Before we start, if you haven't registered for our WhatsApp class yet, it is important to join others who are preparing for the same exam as you and learn with us. The fee is just 1,000 naira for each subject and 2,000 naira for use of English. Like I said earlier, we'll be looking at JAMB 2018 chemistry past question. Now let's dive in. Now let's look at question number 10. In the preparation of oxygen by heating potassium trihydrochlorate in the presence of manganese 2 oxide MnO2, only moderate heat is needed because the catalyst acts by A, lowering the pressure of the reaction, B, increasing the surface area of the reaction, C, increasing the rate of the reaction, D, lowering the energy barrier of the reaction. Alright, this question is simply interested in the action of the catalyst. Now, I want you to understand that first of all, a catalyst is a substance that speeds up the rate of a chemical reaction. And in some cases, it can slow down the rate of a chemical reaction depending on the catalyst you are using and what you want to gain from it. Now, it therefore means that if a reaction should proceed, for a reaction to be completed, if it needs to take like, let's say 20 minutes or 3 hours, there are even some reactions that will take years. All right. So with the presence of a catalyst now, a catalyst will help to speed up the rate of that reaction. All right. If it is supposed to take 20 minutes, with the presence of a catalyst, it will probably take 5 minutes. And then a catalyst affects every area of a reaction. There are some reactions that will require a large amount of heat now before the reaction can proceed. But with the presence of a catalyst, it will only require less heat. Now, looking at this question now, potassium trihydrochlorate, KClO3, will produce oxygen, all right, in the presence of manganese 4 oxide, and this reaction requires a lot of heat. But in the presence, originally it requires a lot of heat, but in the presence of manganese 4 oxide as the catalyst now, only moderate heat is required. Now, this is because catalysts, in essence, affect the rate of a chemical reaction simply by doing only a single thing, which is lowering what we call the energy barrier of the system. Now, for any reaction to occur, there is an energy barrier for the reactants to reach, to overcome. There's an energy barrier. There is that energy that must be overcome before the reaction can proceed, all right, or before the reaction can reach completion. And if that energy barrier is not reached on time, then the reaction will take as many time as it can before it reaches that energy barrier. And sometimes it might take days, it might take a lot of time, it might require a lot of heat. Now, what a catalyst simply does is that it lowers that energy barrier. All right, it lowers it very down so that the reactant can quickly overcome it. So this is how a catalyst affects the rate of a chemical reaction. This is how it speeds it up. First of all, the only criteria, the only option to be overcome before a reaction can proceed is the energy barrier. So what a catalyst does is simply to lower that energy barrier to such an extent that the reacting particles can easily and quickly overcome the barrier. All right, so that is how a catalyst affects the rate of a chemical. That's how it affects a reaction. That's how it speeds up a reaction. All right, so now let's look at the options one more time and then pick out the right one. The first one we'll have is A, lowering the pressure of the reaction, which is wrong, it's not it. B, increasing the surface area of the reaction. All right, this is not it as well. All these are factors that affect the rate of a chemical reaction, right? But we are looking at how a catalyst affects the rate of a chemical reaction, how it is able to speed up the rate of a chemical reaction. Now, C, increasing the rate of the reaction, wrong. D, lowering the energy barrier of the reaction. So D is the correct answer here. All right. Now, question number 11. Methanoic acid mixes with water in all proportion and has about the same boiling point as water. Which of the following methods will you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A, fractional distillation. B, filtration followed by distillation. C, neutralization with sodium hydroxide followed by distillation. And D, neutralization with sodium hydroxide followed by filtration. Now, let's look at this first. First of all, we have that the first information that was given to us here is that methanoic acid mixes with water in odd proportion, meaning that methanoic acid and water are miscible liquids. There are some classes of liquids which we call immiscible liquids, meaning that they will not mix together no matter how you do them, no matter how you mix them. A perfect example is sure red oil or any kind of oil at all with water. If you mix oil or red oil with water now, or even kerosene with water, you discover that they will not mix properly. You will keep on seeing some layers, you keep on seeing dots of the kerosene on top of the water, depending on which one is denser than the other. Alright, so they do not mix together. These classes of mixture is called immiscible liquids, or these classes of liquids, the water and kerosene are immiscible liquids. But not in the case of methanoic acid and water, because in this case now, methanoic acid and water are miscible, meaning that if you mix them together, you won't even know that this is a mixture. You won't even know that these are two liquids together. If I give it to you and I say this is water, you grab it and you drink. Alright, if I give it to you and I say this is methanoic acid, you believe it, because there is nothing, you are not seeing any distinctive layers. It's just a single liquid, homogeneous mixture, right? So now that is the first criteria, or the first information that was given to us. And next information that was given to us is that they have close boiling point. All right, they have about the same boiling point. All right, so when you hear about the same boiling point, it should give you a hint into the kind of separation technique that you should use. All right, so they now say that which of the following method will you adopt to obtain pure water? Now we want to obtain a pure water from a mixture of sand, water, and methanoic acid. Now, if I have this mixture, I want you to know that what you will see in the mixture is just two substances, the sand and the liquid. You won't even know that in the liquid there's a methanoic acid and there's water. So the first thing we would want to do here is to simply get rid of the sand, right? If that is the first thing we need to do from this mixture, now we have three liquids in the mixture, or three substances in the mixture: sand, methanoic acid, and water. So the first thing we will need to do first is to get rid of the sand. Now, how do I get rid of the sand? Very simple, just by using a method, a separation technique called filtration. Now, in filtration, we'll have a filter funnel and a filter paper. Now, you would put the filter paper, we'll arrange the filter paper in such a way that we'll fix it in the filter funnel, and the only thing that can pass through the filter paper is only a liquid substance, and no single particle of a solid substance can pass through that place. Alright, can pass through that filter paper and filter funnel. So with this separation technique, we'll be able to separate our liquid substance, which we will now call the filtrate, and our remaining solid particle now will now stay at the top of the filter paper, which we'll now call our residue. So employing this method, we'll be able to separate our sand particle from the liquid material, right? So from this method, we'll get rid of the sand. So now, having done this now, don't forget that the first thing we did was what? To use a separation technique called filtration. Filtration first. Then what will you follow it by? Now we now have our liquid substance, the filtrate. Now we'll now take it out, and we know that our filtrate is consisting of two liquids, which is what? Yeah, you got it, the methanoic acid and the water. Now, we therefore need to separate the both of them. Now, also, we need pure water. Now, the only separation technique I can use here now, don't forget that they have close boiling point, and the only technique I can use here now is distillation, right? Not fractional distillation, because fractional distillation has to be concerned with a lot of liquids mixed together. Alright, so since we only have two liquids now and they have very close boiling point, then we only employ what? Distillation. So applying distillation now, I'll have to first of all evaporate the substance and then cool it off. So by applying distillation, the method employed in distillation is simply the fact that they do not have the same boiling point, right? They have close boiling point. So now don't forget that when you heat a liquid substance, what happens? You have your liquid substance will start turning to a gaseous substance, right? For example, now if you are boiling your water, you discover that water vapor keeps on going out. That is the gaseous substance. That is the gaseous substance. And then if there is any criteria, or there's any chances that the heat that you were applying before get lost, that gaseous substance will change back to liquid substance, because when you cool any gaseous substance, it turns to liquid. This is what happens in the liquefaction of gases. That is how you are able to have your gas lighter. You see it as a liquid because it is liquefied. All right. So now another vivid example now is when you boil your water. Now when you are boiling your water and then you take the cover, let's say you are using a kettle now or whatsoever. If you take the cover now, if you open the cover, you discover that there is spot of water or drops of water at the cover. Right. Now a lot of people when you have that and immediately you take it, you open the cover, you see that the water is dropping. Now a lot of people think it's because they shook the cover. That was why the drop of water is dropping back. No, it's not because of that. Now what you have here is no longer water again, but steam or water vapor, which is obviously a gas. It is no longer a liquid. And then what makes it a gas is because of the application of temperature. So by the time you open that cover, there was a loss in that temperature. All right, the temperature that was keeping it in the gaseous phase. So since there is a loss in that temperature, it is cooling down, and so it cools back to water and it is dropping back. That is what is happening. And this is also what happens in rainfall, right? Anytime that rain wants to fall, you see that day there will be a whole amount of sun and heat. So all the water bodies keeps on evaporating, and then the temperature from the sun keeps it in that gaseous phase till there is a loss in that temperature. That's why anytime your rain wants to fall, there will be sudden cloud. Everywhere will cool down. So this loss in the temperature, and then the gaseous substance, because there's nothing supporting it in that gaseous phase again, will start returning back to the liquid phase. And this is how your rain fall. Now, how do we need this? This is the method that is employed in the separation of these two liquids now. So since they do not have the same boiling point, one will boil before the other. Methanoic acid has a boiling point of about 90 or so degrees Celsius, while water, the boiling point of water is 100 degrees Celsius. So it means that methanoic acid will boil first. So now if I apply heat now, the methanoic acid will start boiling first, meaning that as it is boiling, the methanoic acid, the liquid now is being converted to gas. It keeps on escaping. Now I'll have a method to trap the gas now and then apply liquid to cool it, so that as my methanoic acid is leaving the system, going up, turning to a gas, I am pulling it into another column, into another beaker now. So by this method, once all my methanoic acid has boiled and I've all separated it into another beaker or another container by cooling it at the upper chamber now, then I'll now be left with what? My pure water, which is void of sand and which is void of any single trace of methanoic acid. So the only separation method, the method that we can adopt now to separate a pure water from a mixture of sand, water, and methanoic acid is simply filtration, which is to get rid of the sand and then followed by distillation. So, and if you look at the options here, the option that carries that is B, filtration followed by distillation. It is not fractional distillation, which is option A. It is not titration with sodium hydroxide followed by distillation, which is C. It is not neutralization with sodium hydroxide followed by filtration. The only answer here is B, distillation followed by filtration. All right, on to the next.